Okay, special lines. Consider the line shown on the right. Maybe you can't even see the line. Maybe I haven't done a good enough job. Let me highlight it. Here's the line I want to talk about. It's a little bit special. We really haven't done any like that. It's called a horizontal line. How am I going to remember that? What's that word inside there? Horizon. That's where the sun sets, right? The horizon. That's why it's called horizontal, because that's where the horizon is, okay? What is the line's y-intercept? So where does this thing meet the y-axis? 7. This next question, is so ridiculously easy, it's difficult.
What?
Yeah. Yeah, weird, right? It's an easy question, except that's what makes it difficult. If a line's horizontal like that, what's its slope? 0. Yeah, weird. It has no slope. Yeah, hold on. We got hang on. Yeah. Okay, so if I went to make the equation of the line, and again, if you're still having trouble, remember, put m and b over top of that. That is a high quality, smart move to put the m and b over top every time. So this one would have slope 0 there, and the y-intercept of 7 there. And that's fine. Maybe you're unimpressed. But what's happened sometimes is we realize 0 times x, well, what's 0 times anything? 0. So that disappears. And what I'm going to do is, so you can still see it, I'm going to get my red highlighter out. Very fine. And I'm just going to basically go, hey, that just goes. That part of it just disappears because it's multiplied by 0. And what you get is a very strange looking equation. Just y equals 7. Oh, I'm still on my highlighter. Y equals 7. It'll catch you off guard because it looks different than y equals mx plus b. I've been like y equals mx plus b, y equals mx plus b, y equals mx plus b. And this comes along and it's just y equals 7. And that means it's a horizontal line. That's all. Do you have any questions? Well, I'm already 1/3 done, friends. Oh, you got a little thing in your sheet, right? In general, all horizontal lines are written as, so in your box there you're going to write y equals b. Instead of y equals mx plus b, it's just y equals b because the slope is 0. All right. Hopefully this is pretty straightforward. If I explain it just right, you're like, okay, it's actually easier than y equals mx plus b, but it won't look like it because it looks different. Here's what we're going to use this to make the equations of these. My first question, are these horizontal? Yes. So there'll just be y equals and just the y-intercept. What's the y-intercept of this one?
6.
Yeah, but negative 6. So boom. And that's all there is to it. And again, I'm going to say it again. These are so easy, they're hard. Yeah, it's like you're expecting something more, and you're like, oh, is it just that? Yep, it's just that. How about this one? Is it horizontal? Yeah. So it's equation just y equals, what is y always equal to? What number? 15. Okay? Is it okay? All right. The only thing I'm going to do is go the other way then. I need someone to describe what's going to happen the other way. The other way goes y equals -9. When you see that, you're like, well, what's the slope? Well, what is the slope if it just says y equals -9? Yeah, it's got no slope. It's got 0 slope, so it's just a horizontal line. Where is it?
-9.
-9. Good. So you just draw a horizontal line. You got your ruler there, hopefully, but I wanted you to see me drawing it at y equals -9. Boom, -9. I say it again. These are so easy, they might trick you a little bit because you're expecting something more. How about y equals 13? What kind of line is that?
Horizontal.
Horizontal where?
13.
At 13. And I want you to see me drawing it, so I didn't use the ruler line. So mine's not as straight as it could be, but I wanted you to see there's y equals 13. All right, we're 1/3 done, the second part of our lesson. Our next kind of special line are lines that go through the origin. They have y-intercept 0. And again, they're pretty easy, but they might fool you because they're so easy. Do you need more time here? Who needs more time? All right. Second part. Take a look at this line. Actually, this one's a little more familiar looking. It's just a regular looking line. But what's its y-intercept? Where does it start on the y-axis? At 0. That's not hard. It's just different and it might catch you off guard. How about the slope? What's the rise and the run here? What do you got? 2 over 3. So you're in great shape slope-wise. You know, like that part you don't got to go back to, right? Because you already, yeah, you got that. So this is 2/3 x plus 0. But I don't really need the plus 0. So these lines will just look like that, and there won't be another number there. And you'll be like, what's the y-intercept? Well, it's 0. See? Very easy, but it'll look difficult when you first see it. And it says, in general, I don't have that box on mine, but do you see the little box up the side? What does it say? In general, all lines through the origin are written as y equals mx. You don't get the b this time. See, we did one where there's no b. Or sorry, there's no m, and now we're doing one with no b. Is that okay? All right. 4 quick practice questions, and then we'll do our last section of the day. Oh, what is the line slope? I forgot to write it over here. Sorry. Did you catch that? Did you write the slope in there? I didn't. I forgot to write that in there. Do you need more time? Time's starting to get interesting here, is it? No, we got lots of time. Still got like 15 minutes. Okay. So, what have you learned? If it goes to the origin, this is just going to be y equals mx, just mx, because we don't need the b anymore because it's got, so then we just need the slope. I don't know. What's the slope of this one?
It's the same as the one in the first one.
Yeah, it looks the same, doesn't it? So 2/3. It might be a little bit different, but when you're estimating, that's okay. How about this one? Does it go through the origin? Yeah, so it's got, again, it's going to be y equals mx. So we just got to find the slope. I think it goes down 2 over 4. I'm going to make a mistake here, see if somebody can catch it. Actually, it's 2 mistakes at once. I wrote that wrong. Y equals mx is all we need here. So I did 2 over 4x. There's 2 mistakes there. I need some help to fix them.
No negatives.
It's a negative, isn't it? Yeah, it goes down. So this is actually negative. And I can do a little better on that fraction.
Well, technically, it's writing a negative. If you're doing a negative rise over run, you should be doing on the opposite side of the line.
Yeah, I did that. We fixed that. But what about this fraction? What happens with this fraction? I could reduce it. Yeah, so watch out for that. And if you have trouble with that, talk to me and we'll talk about how to get your calculator to help with reducing. Okay? But in the end, it's reducing. You just divide top and bottom by 2. Is it okay? It's okay. All right. So, draw the graph of the following lines. So here's me asking you. This has y equals mx, so I can see the slope. But what's the y-intercept? 0. They don't give me one, so it's 0. So I can put that on my graph right now. Y-intercept 0. How about the slope? What do I got to do with this 4 to be able to see the slope better? Because it doesn't have a rise and a run. 4 over 1. Then I can rise 4, run 1, rise 4, run 1, get out my ruler, and this time I will use the ruler tool. And I think I've got the line in red, which actually works pretty good when I'm on the board here, so you can see that. And I'll do it all again. You see this line, and it says y equals negative 4/3 x. And you write over top of it y equals mx plus b. But there's no b. What's the b? It's no b. Zero. So that's a 0. And then all I got to do is the slope, which is negative 4/3. Watch the scale on this one, though. Look at the scales by 2s. I don't like that. Maybe you don't like it. You're like, I wouldn't do that. Yeah? And if that happens on a quiz or a test, you can always ask for a piece of graph paper and go, no, I'm going to do it my way. But if we're going to use their scale, watch. Down 4 over only 3 goes to there because the scale's in 2s, yes? And then down 4 over 3 goes to there. That's really awkward. You really got to be careful when the scale's not what you expect it to be. There's my line. We have one last little thing. First, we're going to close the door, shut down a bunch of the noise. Kids these days. Sorry, video people. You might have heard a couple of swears on there today. Ugh. Okay, last type, last kind. Here we go. Vertical lines. Here, maybe you can't see it very well on your page. There's the line I'm talking about, a vertical line. Draw 5 points on the line. Okay, here I go. 1, 2, 3, 4, 5. List the coordinates of the 5 points below. So this one was 3, negative 5. This one was 3, 0. This one's 3, 1. This one's 3, 4. And this one's 3, 8. I put them on the graph, but you can put them over here as well. What 3, 8, 3, 4, 3, 1, 3, 0, 3, negative 5. I'm getting tired copying these all over. What do all the points have in common? Yeah, that's right. Their x value, that's just the word you're after there. Their x value is what? 3. It's 3. So this line is very strange. Straight up and down, it won't look like all the other lines. Its equation actually is x equals. It's the one line that we write x equals instead of y equals, because all the x values are 3. So vertical lines are x equals. Ew, some extra stuff to remember there. Vertical lines are just x equals. So all vertical lines will be written as, down the corner there, you got a little review thing, x equals, and we just write x equals a, because b is reserved for y-intercept, so we'll use a for x-intercept. Okay, if that freaks you out a little bit, that's okay. These are weird lines. The other ones are all like, okay, those are just special cases, but these ones are a little bit different and weird. So you may have to flip back and forth on this one for our 3 examples. So, what would the equation of this line be? It's a vertical line at the x value negative 5. If it's vertical, it no longer will be y equals. It's now x equals. And what value? It's at x value negative 5. How about this one? Is it vertical? Yeah. At what x value?
9.
9. See, they're easy, except they're not, because they're weird. Yeah? Troublesome little special lines, yeah? We got one more to go. One more to go. I'm not trying to rush you, though. Do you need more time here? You do need more time there? Okay. Take your time. We'll pause and take our time on the last one. Last one. Draw the graph of a line that's x equals 13. If it's x equals 13, will it be vertical or will it be horizontal? That's a big question. If all the x values are the same, if we always have x value 13, here, watch me do it. You got to watch me on the thing go. If all the x values are 13, you see how it's going up like that? That's vertical. And let me show you. I'm going to draw a bunch of points. See? X equals 13, right there. X equals 13. X equals 13. X equals 13. X equals 13. It's all those points. That's how I get a vertical line. Ooh, I even have a vertical line tool on mine. So it's a straight down line like there at x equals 13. I won't lie, those are weird. That's going to take a little practice and a little studying to be ready for those. And on that page, I think I do have the right homework. Yes? If you just flip in behind there, the homework's in behind there. So you got about 5 or 6 minutes to do a little bit of that homework. And fair warning, tomorrow is assignment day. I've got an assignment for you, plus you can work on old riddle assignments. So you got lots of time there.